one. We have commit. We have liftoff.
An Apollo mission begins as it ends in a searing mass of flame and heat. Project Apollo. Its mission, a lunar landing, exploration of the moon's surface, and the safe return to Earth of the three-man crew. On an Apollo lunar mission, the final critical phase begins with fiery re-entry into the Earth's atmosphere. A camera on board an Apollo test mission vividly depicts the tremendous heat encountered by the spacecraft. For nearly 1,000 seconds, as the command module smashes into the atmosphere, it will be exposed to heat which can rise to over 5,000 degrees Fahrenheit. With only inches between their 75-degree cabin and the scorching exterior, astronauts returning from a lunar mission will be protected from the elements by a self-consuming ablative heat shield. During re-entry, the heat shield is exposed to sharply rising temperatures. The shield reflects a large part of the heat and dissipates the remaining heat by surface melting, decomposition during charring, and by cooling at the surface. The cooling is caused by the gases of decomposition as they percolate to the surface of the ablator. In this way, heat bombarding the heat shield is blocked from traveling back to the metal surface of the spacecraft. Developed and produced by Avco Space Systems Division in Lowell, Massachusetts, the ablative heat shield is the result of over 3 years of intensive research by the division. Actual manufacture of the heat shield begins with the arrival of the command module substructure from the Space Division of North American Rockwell Corporation, prime contractors for NASA's Apollo program. The command module arrives at Hanscom Air Force Base in Bedford, Massachusetts, aboard a specially designed plane known as the Pregnant Guppy. The Guppy is a converted stratocruiser utilized to airlift large shipments that cannot be carried by conventional planes. The module arrives from North American's Downey, California plant in 3 sections: the forward section, the main crew compartment, and the blunt aft section. Crates containing the 3 pieces are loaded onto large flatbed trailers and then transported to Avco. Because weight is of extreme importance in any space mission, technicians carefully weigh each component, make center of gravity determinations for each section, and perform initial measurement operations. After a special cleaning process, strips of fiberglass honeycomb, which form the base of the ablative heat shield, are fitted to the sections. The sections are then fixed to the spacecraft's stainless steel outer shell with a special adhesive. They are then heat bonded in a giant oven. The techniques for fitting and bonding the honeycomb were developed by Avco specifically for the Apollo mission. In all, the honeycomb consists of more than 370,000 individual and separate cells. Later, they will be filled one by one. There is no room for error in the bonding of the honeycomb to the substructure. To ensure uniformity of bonding, ultrasonic testing, utilizing sound waves, is performed all along the entire vehicle. The bonded sections are machined on a huge electronically controlled lathe. Because re-entry heats will vary across the surface of the spacecraft, required thicknesses of the heat shield must also vary. After machining, a coat of gray primer is applied to all sections. The heart of the heat shield application comes with the insertion of the ablative material into the machined honeycomb. This is the section occupied by the three-man crew during manned missions. Since conventional equipment could not handle the fibrous ablative material, Avco developed and manufactured special injection guns. The gunning operation is a meticulous one. Each gunner must constantly exercise intense concentration. All of the gunners are therefore specially trained and certified for the heat shield assignment. Because of its huge dimensions, the aft section is placed on a vertical rig so that the gunners can work on the entire surface simultaneously. The aft section is the first part of the spacecraft to re-enter the Earth's atmosphere. It must bear the brunt of re-entry heat. The three sections, now completely filled, are placed in ovens for curing. The sections are covered with rubber vacuum bags. Depending upon the section being cured, the process may require from a few hours to as many as 4 days. Because of the critical weight factor, it is necessary to grind away much of the ablative material in those areas of less severe heating. To achieve the varying and precise thicknesses required, 2 huge lathes controlled by computer tapes contour the heat shield sections with extreme accuracy. To verify the thicknesses of the heat shield, depth measurements are taken through holes left for that purpose. The holes are then refilled. X-ray inspection locates defective cells. To ensure that no voids, broken, or improperly filled cells exist, detailed X-rays are taken of all sections of the module. Areas which do not meet the exacting requirements are marked by the technician to be drilled out and refilled with ablative material. Despite its unusual size and shape, even the aft section is X-rayed, but in a different manner from other sections of the command module. Each section is inspected again and returned to the ovens for final curing. In the final steps, gaskets are installed to join all sections together. Clear, high-gloss primer and a coat of white protective sealer are applied. Following final acceptance of completed vehicles by representatives of North American Rockwell Corporation and NASA's Manned Spacecraft Center, the sections are returned to Downey, California. In North American's clean room, the world's largest, an assembled Apollo Command Module outer heat shield is fitted over the inner crew compartment and mated with the rest of the spacecraft. The Apollo heat shield is now ready to protect the three-man crew during the return trip from the moon. The command module is the only part of the entire spacecraft system that will complete the 500,000-mile trip to the moon and back. More than 300,000 scientists, engineers, technicians, and craftsmen from over 20,000 companies have committed their talents and efforts to Project Apollo. Talents and efforts which are bringing ever closer this country's first manned journey to the moon.